Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We open this session with Al-Fatihah. Okay, amin amin ya rabbal alamin. Okay, good morning everyone. So, okay, we will continue to discuss stiffness matrix method. This is beam analysis. So today we are going to discuss beam analysis. Actually, I have made one video last night. Okay, I review chapter number 15 in textbook. Because stiffness matrix method in the textbook, it is divided into three topic. Okay, topic 14 for truss analysis, topic 15 for beam, and topic 16 for frame analysis. Okay, you can watch the video back. Okay, after this session, actually in the video I have gone through some of introduction about beam analysis, and then I also skip. Okay, okay, skip banyak jugalah from the textbook. Dia ada dia punya subsection in the textbook yang saya skip. So all that sebab dia tunjuk banyak derivation how actually the formula to calculate element global stiffness matrices are derived. Okay, so what we need to continue is actually we want to focus on how we can analyze element global stiffness matrices using the formula, okay, that have been derived. So the procedure will be the same with what we have learned previously in truss. We will start with identification. We have to label all the degree of freedom. So we label the degree of freedom according to unconstrained and constrained. So for beam dia special sikit. Kalau compare to truss, beam dia special sebab basically deflection in beam, kalau yang normal structure macam yang kita nampak dekat sini, structure yang macam ni kan, dia punya displacement, unknown displacement in unconstrained system tu is actually the unknown rotation in the system. Okay, in the system, basically. Okay, so semua tu saya ada explain dalam video tadi. Saya ada explain juga how we identify nodes. Okay, how we identify nodes. So nodes ni not necessary pada join tu sahaja node. So ada lagi definition node yang lain. Okay, so semua tu saya dah explain dalam short video. Okay, yang saya dah share link tadi. Okay, so kita akan fokus on how we put the degree of freedom for beam. So kita akan start nanti dengan macam mana kita nak tengok beam ni conventionally and using stiffness method, how we try to relate between the label that we use, displacement D1 sampai D6. Okay, in this case Q1 sampai Q6 representing what in conventional way when we analyze beam using flexibility method. Okay, kita akan tengok dia in two separate condition. Okay, and try to relate it back lah. After that kita akan continue with identification, or as we will establish the structure stiffness matrix. The structure stiffness matrix. So as usual, we analyze elements sebab in order to establish the structure stiffness matrix, we have to analyze element. That's why dekat sini pun dalam buku teks memang ada mention again about the statement, this statement. Dia kata divide the structure into element, because we can only determine or establish the K, okay, by element. Sebab formula to identify K is come from element. Okay, come from element. It is element stiffness matrices. So dah dapat yang tu, make sure susun betul-betul, label betul-betul according to right label, degree of freedom label, and then baru kita boleh produce the right K. So after that kita akan apply the stiffness relation, relation or stiffness equation or force displacement equation in order to analyze number one, displacement. Okay, we use stiffness method to analyze displacement first, and after that we will analyze unknown reaction. So kita tengok dulu diagram ni. Okay, kita tengok diagram ni. Okay, so by looking at this diagram, kita nak study about diagram. So kita tengok diagram ni, cuba tengok diagram ni as conventional. As conventional maksudnya kalau kita analyze this beam guna flexibility method, apa yang kita buat? Apa yang kita identify? Macam mana kita nak draw dia punya deflected shape? Okay, deflected shape of this beam. Okay, according to load shown, macam mana dia jadi? Okay, macam mana dia deflect? So macam mana dia deflect tu? Okay, it will be depend on the support condition jugalah, support condition. So kita tengok macam mana kita draw the deflection, okay, of this, okay, due to the load shown. Okay, so kita tengok kat sini dia ada point load at the center, So kita akan, sebab dia fix dekat hujung, sini dia fix kan? Sebab sini fix dekat hujung, so fix we know that at fix, dia punya effective length, you dah belajar about effective length juga, effective length ni. You dah belajar about effective length. Okay, effective length ni masa part 24 juga kan, effective length. Effective length tu maksudnya dia punya deflection tu, berapa dia punya distance. Okay, effective length. Kalau between fix dengan roller, effective length dia berapa. Kalau between pin dengan pin, berapa dia punya effective length. You remember? Tapi belajar pada column. Nak under buckling or column. Tapi that behavior tu kita apply juga untuk beam. Okay, contohnya kan, masa tu you belajar about okay, kalau kat sini pin dengan pin. Kat sini pin dengan pin. How it buckle. Kalau kat sini fix dengan fix. Okay, kalau kat sini fix dengan fix. Okay, kalau fix dengan fix macam mana? So kalau fix dengan fix, berapa dia punya effective length? Kalau ni pin dengan pin, dia punya effective length dia berapa? Do you remember this? Kalau between for example between satu fix, satu pin dekat sini. So effective length dia macam mana? So dekat pin tu dia dah sini dah sampai hujung, sini sampai separuh. Do you remember all this? Okay, you belajar ni under buckling of column, remember? Ingat lagi tak benda ni?
Yes, madam.
Okay, so belajar ni under buckling pada column, tapi dia punya behavior tu kita actually can apply to beam also. Okay, so dia punya behavior tu maksudnya effective length means deflection dia tu, deflection. Okay, dia punya deflection distance tu between support. Okay, between support. So kalau dia pin, kalau dia roller, effective length dia satu lah. Kan ni satu lah effective length. Okay, kalau between fix dengan fix dia jadi 0.5 LE. So satu ni LE lah. Satu LE. Lepas tu kalau fix dengan pin or fix dengan roller, effective length dia about 0.75. Lepas tu kalau dia satu pin, satu lagi cantilever, so dia jadi dua effective length. Okay, semua tu kita akan apply bila kita nak draw yang ni jugalah, deflected shape for this beam. Okay, so deflected shape for this, because A tu fix, B tu roller, B roller kan, B roller. So effective length between these two joint, between A and B, berapa dia punya effective length? Dekat A boleh draw macam ni ke? Boleh ke draw A tu macam tu?
Tak.
Tak boleh kan? Sebab kat sini fix. So fix tak boleh lah. Tak boleh draw dia macam ni sebab fix between fix dengan roller tu dia 0.75. So we cannot put okay the deflection like this. So because the effective length tu lebih kurang Sekejap. Okay macam ni. Okay, it is about 0.75. Okay, effective length. Okay, and between B and C, dia punya deflection, length of deflection tu, effective length, berapa? 1 lah kan? 1. Is it right? Betul tak 1? Between roller and roller?
Ya, betul madam.
Okay, so this is actually deflection occur whenever the beam is loaded by all this loading lah. Ada point load, ada UDL. Okay, moment tu tak apa, moment tu dekat support kan. Okay, point load dengan UDL. So dia akan deflect like this. And we should be able to read because it relate dengan degree of freedom. Degree of freedom kita ni, okay, degree of freedom kan kita akan measure in Y direction and in Z direction. We don't need to count in X direction because X, kalau beam X, AX 0, displacement in X also 0. So that is why we only count these 2 degree of freedom in beam. And these 2 degree of freedom in beam, we need to apply in terms of what? In terms of displacement and in terms of forces. In terms of displacement and in terms of forces. Okay, means that displacement in Y direction, displacement in Z direction. Okay, what is displacement in Y direction? Siapa tahu? Displacement in Y direction selalu kita sebut sebagai apa? Displacement in Y direction. Displacement in Y direction. Vertical displacement is also known as vertical displacement. Vertical displacement is also known as apa dia vertical displacement? Nama lain bagi vertical displacement. Kalau beam kita ukur apa? Selain daripada we call it as vertical displacement, apa lagi nama lain kita pakai for this vertical displacement? Apa lagi? Apa lagi kita pakai term lain? Kita pakai to represent vertical displacement. Dah belajar dah masa last semester dah belajar dah. Ada topik lagi. Nama tu. Okay, what is the other name of vertical displacement? Displacement, nampak tak displacement apa? What is the other name of vertical displacement? Name of one of the topic under CS424. Nama lain bagi vertical displacement. Apa nama lain bagi vertical displacement? Pergi cari sekarang. Nama lain bagi vertical displacement. Before I continue. Cepat cari nama lain bagi vertical displacement.
Rotational displacement.
Rotational is in other direction. Vertical and rotational. Vertical yang ni. This is vertical. This is rotational. Vertical in Y direction, rotational Z direction. What is the other name of vertical displacement? It is actually one of the topic in CS424. The name of the topic. Nama lain bagi displacement. Displacement ni ada banyak word yang describe the same thing. Not only displacement, other name of displacement. Selain guna word displacement, nama lain.
Deflection.
Yes, deflection. What is the symbol of deflection? What is the symbol of deflection? What is the symbol for deflection that you used previously? What is the topic you calculate deflection that you have learned in CS424?
Delta D.
Okay, it is delta. Delta. Okay, delta ni, okay, delta is also displacement. So displacement ni ada banyak word describing deflection. It is actually come from the word deformation, ubah bentuk. Deformation, asal dia daripada deformation. Deformation ni ada, kita juga panggil dia as displacement. Kita juga panggil dia as deflection. Deflection. And normally kalau deflection ni kita banyak anggap yang ni lah. Okay, beam deflect. Okay, deflect means vertical displacement. Okay, ada lagi nama lain for deformation ni. Rotation, tapi arah dia bukan arah ni lah, rotation. Is nama lain for deformation or displacement. Ada lagi nama lain. What is nama lain for rotation? Selain daripada we call as rotation. Okay, Z displacement we call as rotation. Ada nama lain tak for rotation? Ada tak nama lain for rotation? Nama lain for rotation?
Angular displacement.
Okay, other than angular displacement? Just a simple word. Rotation, ada nama lain for rotation? And you have actually used it before. Rotation. And dia ada pada diagram ni. Okay, displacement, deflection, rotation. Okay, angular displacement ni dia sama dengan rotational displacement. Rotational displacement. Ada lagi nama lain bagi rotation. It is a simple word to represent the same thing, rotation. Apa nama lain bagi rotation? Okay, user sekarang nama lain selain daripada we call it as rotation. Rotation, nama lain. Selain daripada word displacement. Rotation is also called as what? Rotation.
Turning.
No. Dia satu patah perkataan je. You sebut dia sekali je. Rotation 3 kali, tiga suku kata. Rotation. Ni satu kali sebut je. Rotation. The other name of rotation.
Moment.
No, moment is forces. Now we talk about displacement. Moment is forces. One of the forces. Moment is Q. Now we talk about D. Displacement. Displacement. Okay, displacement comes from the word deformation. Okay, deformation ni dia ada banyak bentuk lah. Dia panggil kalau simple word in Malay we call it as ubah bentuk, deformation. And deformation ni bila kita look at it in X, Y and Z direction, we have all these three comes from forces. Because we have shear force, we have shear force, we have axial force, and we have moment. And all the displacement come from moment induced rotation. Shear force induced deflection. Forces induced deflection. Okay, deflection or vertical displacement. Okay, it is one other name to represent the word rotation. What is it?
Torque.
Apa dia? Torque
Torque.
tak sampai sejauh tu. It is a simple word.
Here.
Ya?
Spin.
Apa tu?
Spin.
Dia start from
Shear.
S. Shear is force. Shear tu, shear force, forces. It is now displacement. Nama lain bagi rotation. Start from S.
Spin.
No. Cepat, nama lain bagi rotation. It is very simple word and you have meet the word banyak kali daripada start you belajar analisis. Sebab when talking about beam, dia memang akan ada dua-dua tu. Rotation and deflection. Deflection dia ada nama lain. Now I ask you what is nama lain bagi rotation? Start from S. Yes, slope. It is slope. And we use the symbol for rotation and slope as theta. Isn't it? Theta, slope. It is theta. Okay, the other word, kalau deflection ni dia common with vertical displacement. So deflection ni the common direction is vertical deflection. When we use delta, we call it as deflection. Okay, it is a vertical displacement and horizontal displacement. Still we use the same symbol. It is delta. Okay, but when we call deflection, it refers to actually the vertical displacement. And there is also the term that reflect the horizontal displacement. Still the word delta, tapi delta when we use for representing horizontal displacement. What is another word to represent it? Kalau delta, kalau vertical displacement ni, okay, it is vertical displacement. Vertical displacement we also call as deflection. So deflection ni when we talk about deflection, kita faham yang deflection tu vertically, okay, vertical. Kalau delta tapi we describe the horizontal displacement. It is delta but we describe horizontal displacement. Ada nama lain juga. Okay, also start from S. Delta that we use to reflect horizontal displacement. Settlement also for vertical. Settle. Okay, settlement also, settlement dia duduk kat sini. And settlement ni normally due to support. Okay, delta, okay, when it reflect to horizontal displacement, pun ada nama lain juga. What is the word? Juga start from S. Ada 4 huruf je.
Slip.
Slip tu dia sama macam yang ni. Slip. Slip. Slip boleh pakai untuk dua-dua jugalah. Tapi ada satu lagi word yang kita normally use for horizontal displacement and we will apply it banyak kali for the third chapter. And for those who actually yang daripada diploma pun dah pernah dengar benda ni. Okay, we have slip. Slip also we can put it here. Slip. Tapi what I mean is another word name sway. Sway tak pernah dengar ya? Sway. Sway ni reflect kepada horizontal displacement. So yang ni. So this is delta, this is also delta. Ni negatif, ni positif. So yang ini kita panggil dia sway. Okay, sway. Dia vibrate back and forth. Okay, sway. Sway ataupun building bila we have frame. When we have frame and then ada loading. Okay, the frame we call it as side sway frame. Side sway frame. So ni pun delta juga. And this delta we call it as sway. Sway. Tapi nak bagi sedap sebut, tak sebut sway lah, sebut side sway. Okay. Side sway. Okay, so ni semua nama-nama bagi displacement. Okay, ada banyak nama representing the same behavior. It is representing deformation, ubah bentuk. Okay, so yang kita biasa pakai is delta and rotation. Deflection and rotation. Deflection tu refers to what? Rotation tu refers to what? So rotation ni is also called as slope. Okay, representing rotational displacement. Yang tu rotation. Okay, and simbol dia kita pakai theta. Okay, simbol untuk rotational displacement we use theta. And for deflection we use delta. And deflection normally kalau we talking about beam, bila kita sebut deflection kita understand yang deflection tu dia downward. Deflection dia downward. Kalau settle pun downward. Slip boleh jadi horizontal juga. Slip to the right direction, slip to the left direction. Okay, yang tu slip. Tapi kalau untuk for example macam kita ada frame, bila ada loading yang push from one side, so the frame will side sway to the other side. Yang tu kita panggil dia side sway. Okay, sway yang tu pun sama juga, it is come from displacement. It is horizontal displacement. So horizontal displacement, side sway. Okay, side sway. Lepas tu kita ada vertical displacement, deflection. So we also have rotational displacement, slope or rotation. And the common symbol that we always use to represent all this displacement, dia relate pada ni. Okay, P and delta. P and delta, and another one is moment theta. Okay, so P delta ni is very common principle juga in structural analysis. We call it as P delta effect. Okay, P delta effect. P delta ni macam yang sama je konsep macam yang saya pernah explain dalam previous video, tak ingat dalam video kelas mana. Okay, P dengan delta ni kita punya graf tu. This is P, this is delta. Okay, P dengan delta. So bila kita ada graph for we use static, okay, for static analysis. So dia macam ni dia punya graph. Okay, P delta. And where is K? K is kecerunan ni. So this is K. Okay, P and delta. So P dengan delta ni kalau kita pakai, kita change the term to term yang kita pakai in stiffness method. P ni adalah Q. Okay, P ni adalah Q. Okay, P adalah Q and delta adalah displacement. Okay, delta adalah D lah, D. Q dengan D. Sebab Q ni dia boleh represent moment sebab Q forces. Q forces can be representing moment, vertical force, horizontal force. P normally kita refer pada either horizontal or vertical forces only. So that's why P tu dia partner dia dengan delta. Delta can be horizontal, delta can be vertical. So why we have the stiffness equation where the formula is Q is equal to KD sebab K ni kecerunan. Kecerunan K ni, okay, kita nak dapat value K from the graph, it is Q divided by D. That is why kita dapat the equation that we use to analyze structure is Q is equal to KD. So Q is equal to KD ni is what we call as force displacement equation. Force displacement equation cuma in stiffness method kita pakai dia in matrix form. In matrix form. So this is how we actually get the relationship. So it is P delta, come from P delta. Cuma P ni kita pakai untuk X and Y. So delta can be horizontal deflection, can be vertical deflection. Okay, and for M theta, M also Q, theta also D. Okay, tapi when it is M moment, it is moment macam ni lah bentuk dia kan, moment kan. So moment ni induced rotation, So it can be yang ni maksudnya rotational displacement. Okay, and moment lah sini dia punya Q. Okay, so MQ ni, bukan MQ, M theta ni we call as in structure, we call the name as moment curvature. P dengan delta ni kita panggil dia P delta effect. M dengan theta ni kita panggil dia moment curvature. Nanti bila you further study on structure, you akan jumpa lagi lah term-term ni. P delta effect as well as moment curvature, M theta. Okay, so nama-nama bagi ni, you have to get familiar. Okay, go back to this. Okay, go back to this. Means that in terms of the degree of freedom in beam, and we only count in Y direction, in Y and Z direction. We don't need to count X. It means that okay, and Y and Z tu in terms of deflection, ingat degree of freedom ni represent displacement component. So cara paling mudah untuk kita identify dekat support condition. So kita kena tengok in terms of delta, in terms of theta. Okay, this is actually delta dengan theta ni is actually represent degree of freedom. Means that dekat delta kat sini refers to vertical deflection lah, so this is for Y direction and theta tu is for Z direction. So this 2 degree of freedom per node ni yang kita panggil 2 degree of freedom per node ni, means that at each node we have to have 2 degree of freedom per node, so that we need to put at support. Okay, means that we need to apply Y, Z kat sini, Y, Z dekat sini, Y, Z dekat sini. So Y, Z ni representing apa? Representing delta and representing theta. Okay, now tengok dia dalam bentuk delta and theta. Pada A, pada B, pada C. Okay, at A. So setiap join ni ada delta, ada theta. So what is theta A? What is delta A? Theta and delta A. What is the value? By looking at the deflection that I have drawn just now. Dekat A tu, what is the value for delta A and theta A. What is the value? What is the value? From the deflected shape ni kat sini, kenapa kita lukis tu, kita tak lukis
0.
okey, sebab kat sini dia 0 kan. So at fixed support, delta is 0. Delta is 0. Theta is also 0. Okay, delta is 0, theta is also 0. Okay, now look at B. Look at B. Ada delta, ada theta. Okay, from the deflected shape that we have, okay, sketch. Ada delta B, ada theta B. Delta B and theta B. So delta B and theta B ni mana yang 0? Delta B.
Delta yang 0.
Delta 0. Theta B.
Negative 30.
Theta B. Theta bukan moment this is slope. 30 tu is moment, forces, Q. Now we talking about D, displacement. Displacement. Kena boleh bezakan forces dengan displacement. Displacement, forces induce displacement. Now we are talking about displacement. 30 tu moment. Moment yang induce rotation tu. Okay, delta B kita dapat from sini. By looking at the diagram, looking at the deflected shape, it is proven that delta B is equal to 0. Sebab tu kita draw, bila kita draw tu dia balik dekat kosong balik kat sini. Okay, dia akan going back to 0 sebab delta dia 0. So theta B. Theta B 0 or non-zero?
0.
Theta B. Where is theta B in the diagram?
Non-zero.
It is non-zero. It is non-zero. Mana dia theta B in the diagram? Pernah belajar tak lukis tangent line ni? Pernah belajar tak lukis tangent line ni? This is theta B. Theta B. 0 or non-zero? 0 or non-zero?
Non-zero.
Non-zero. Non-zero. Non-zero. Okay, move to C. Move to C, we have theta C, we have delta C. We have theta C, we have delta C. Theta C and delta C. Why we have delta and theta? Sebab 2 degree of freedom. 2 degree of freedom. Delta tu Y punya direction. Theta tu Z punya direction. That's why we have 2. Okay, we have 2 degree of freedom. Okay, at C, mana yang 0? Mana yang non-zero? Which one is 0? Deflection or rotation? Equal to 0.
Deflection.
Deflection is 0. Deflection at C is 0 sebab dia patah balik kat 0 tu kan. So yang tangent line tu represent? The tangent line represent? Theta at C. Okay. Bila theta ni 0, pada fixed support. That's why bila kita draw ni, kita tak draw dia daripada hujung. Sebab dia 0 kat sini. 0. Theta 0. So at fixed theta 0, delta pun 0 at fixed. At pin or roller, tengok pada diagram tu lah, tengok pada diagram. So deflected shape yang kita draw tu is to guide us to identify mana dia non-zero, mana dia 0. Okay, so yang mana yang kita nampak macam ni, memang kita nampak we can draw the tangent line from the curve line. So it is represent the slope. Okay, the slope or the rotation. So that's why yang ni dia jadi non-zero. Ini jadi non-zero. Okay, jadi non-zero. This is also non-zero. So non-zero ni unknown lah, unknown. Non-zero, so dalam sini, dalam diagram ni, dia ada zero and non-zero. Zero and non-zero tu lah yang reflect pada unconstrained and constrained. Zero and non-zero reflect pada constrained and unconstrained. So dia beam macam ni. Okay, dia beam. Kita ada fix dekat sini. Kita ada roller sini, roller dekat sini. Okay. So at each joint, so we join that, joint A. Okay, we have joint A, joint B, joint C. Joint A, joint B, joint C. Lepas tu dia ada loading. Dia ada UDL. Okay, loading tu Q. Forces. Okay, due to loading, dia akan deflect. Due to loading, dia akan deflect. So, deflect macam ni. So, deflection tu dia depend pada effective length tu. Effective length tu is actually the deflection punya length. Okay, so between roller dengan roller, satu kan? Roller dengan roller, satu. Fix dengan roller, 0.75. Okay, fix dengan 0.75. So, macam tadilah. Okay, actually bila kita boleh draw, kita boleh sketch this deflection, okay, dia akan guide us untuk identify between delta and theta. So, setiap node ni dia akan ada delta, dia akan ada theta. So, delta and theta. Delta and theta. Delta and theta. So, what is delta and theta ni? It is degree of freedom. It is degree of freedom in y direction and z direction. So in y direction is delta, okay, z direction theta. Okay, so from this, okay, deflected shape, so we can be able to identify mana dia zero displacement, mana dia non-zero displacement. So at A, due to fixed support, both deflection, okay, both delta and theta are zero. Okay, so yang ni pun zero, yang ni pun zero. Sebab nampak kat situ memang zero. Okay, dekat B, delta dia zero, tapi theta dia tu, slope dia tu. Okay, tangent line tu dia ada slope. So slope tu dia kat sini dia jadi unknown, non-zero. Okay, sama juga dekat C, delta tu balik, dia punya delta tu kan dekat situ kosong. Sebab delta ni vertical displacement. So sini mana ada vertical displacement kan dekat C tu. So yang ni kosong, delta kosong, theta unknown. So dekat sini ada two things. Okay, ada two things. Apa dia two things tu? Zero displacement and non-zero displacement. So non-zero displacement ni lah dia unknown displacement. Unknown displacement. Non-zero displacement is unknown displacement. Zero displacement apa? Zero displacement means that zero displacement dekat mana? Dekat support. Dekat support there's no deflection, there's no displacement. Zero displacement. Cuba kita relate back dengan what should we label for degree of freedom. Okay, degree of freedom we label like this. Okay, we have beam. Okay, we have node 1, node 2, node 3, A, B, C pun boleh. A, B, C. Okay, we have two because we want to do it separately. A, B, C. A, B, C, A, B, C. Okay, so yang atas ni unconstrained. Yang bawah ni constrained. So how we identify degree of freedom in constraint system? How? Kita tengok pada support condition, right? Pada support condition. Okay, based on this, okay, based on ABC tu, ABC, degree of freedom, how many? How many unknown reaction at A? We identify from unknown reaction. How many? What is the value of unknown reaction? How many unknown reaction at A? Due to support condition. Dekat A. Unknown reaction, how many?
2.
3.
Okay, it is 3, but we only count 2 because we only count Y and Z. So we have 2. Okay, here we have 2. Okay, at B, how many unknown reaction at B? How many?
1.
1 because of roller. Okay, another 1 dekat C kan. So total ni dapat 4 DOF. In 4 DOF in constraint system. So kita tengok kat situ dekat A kena letak. Dekat A tu we have to put, at A we have to put 2 DOF. 2 DOF at A. We have to put 2 at A. Okay, at B we have to put 1. At C we have to put 1. So total is 4. 4 ni represent 4 unknown reaction. Okay, it is actually 5 kalau kita based on support. Tapi we don't count X in at fixed support, so we minus by 1. So that is why we get 4. This is 4 unknown reaction. Okay, represent 4 degree of freedom in constraint system. In constraint system. Okay, and in total we should have 6 degree of freedom because there are 3 nodes. And we should complete the 2 DOF per node. So at A now we have 2, which is located in constraint system. At B we have 1 in constraint, means that we have remaining 1 in unconstrained system. So we have to put Z, okay, this Z direction, okay, at B in unconstrained system. So that when we combine dia akan jadi Y and Z. So dia mesti ada YZ, YZ, YZ. Cuma kita nak label tu according to unconstrained and constrained. So dekat C, in constraint we have Y. So remaining 1 in unconstrained system. So dapat macam ni lah. Okay, dapat macam ni. So nampak tak? We have 2 DOF and we have 4 DOF. Okay, 2 DOF and 4 DOF. So 2 DOF in unconstrained system representing D1 and D2. Representing D1 and D2, non-zero. This is non-zero displacement. Okay, D1, D2, this is non-zero displacement. D1 and D2 ni, okay, D1 and D2 ni apa dia dalam ni? Dalam ni tadi. Mana dia D1 and D2 tu? Kat mana? Kat mana D1 and D2? Dalam ni, dalam 66 ni, mana dia zero, mana dia non-zero? Yang ni non-zero kan? Yang ni non-zero kan? Yang ni ni non-zero. Yang ni non-zero. So ada how many non-zero? How many? Ada 2. So 2 tu represent 2 unknown displacement. Sama tak dengan kat sini? 2 unknown displacement? 2 unknown displacement. Sama. So 2 unknown displacement. Okay, 2 unknown displacement. 2 unknown displacement dekat sini. Okay, for the slope, for the rotation at B, rotation at C is actually representing D1 and D2 in unconstrained system. And then we have here non-value, 0, 0 and non-zero. We have 0 displacement at 4 position. 0 displacement at 4 position. Where is it? The 4 0 displacement tu. Ada pada constraint, right? So 1, 2 dia dekat unconstrained. So remaining ada 4. Remaining 4 ada pada D3, D4, D5, D6. So semua ni 0. This is 0 displacement. 0 displacement yang dalam diagram tadi kita dah label 0 tu macam ni. Okay, yang kita dah label macam ni. So delta dekat A ada 2 0 displacement for delta and for theta. And pada B we have 0 displacement pada delta. And at C we have 0 displacement pada theta. Okay, pada theta. So that's how we try to integrate between conventional way when we want to imagine. That's why saya kata as engineer memang you have to be able to imagine. Sebab benda ni you tak boleh nampak dengan mata kasar. Okay, because displacement in structure is very small. Dia mm je. So memang dengan mata tak boleh nampak. Tapi you as engineer you kena boleh imagine all this. Kena boleh imagine dia punya slope, kena boleh imagine dia punya deflection. Kena usaha untuk imagine. Dan kena boleh relate. Kalau that's why saya pernah sebut dalam video-video before this about the physical meaning. The physical meaning. Okay, physical meaning. So what is physical meaning? For example, okay, kita go back to this. Okay, go back to this. Tadi belum label kan? Tadi kita belum label. Okay, now we have 6 degree of freedom and we do not yet label it. Okay, so in unconstrained system, we have 2 degree of freedom labeled as 1 and 2. So we can label as 1, 2. 1 and 2. And we have remaining 4. So we continue to label 3, 4, 5, 6. 3, 4, 5, 6. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So in terms of, okay, so we have D1 until D6. We have D1 until D6. Okay, now try to compare this dengan yang atas tadi. D1, what is the meaning of D1? Looking at this diagram, looking at this position. Okay, we look at this position. Kejap, mana dia? Okay, we look at this position. Okay, D1. Siapa tahu? D1 represent apa dalam ni? D1. D1 which is non-zero displacement. D1 dalam diagram ni yang dia tunjuk arah Z yang dia label as 1 tu, dalam diagram ni dia represent apa? At B. Location dia sama dekat B. So it represent what? Kena compare dua-dua ni. Kena compare dua-dua tu. D1 representing mana satu? Representing delta or representing theta?
Theta.
Theta.
Theta. D1 representing theta. So it is actually, okay, D1 means rotation at what? At which position?
At B.
Rotation at B. D1 is rotation at B. D2?
Rotation at C.
D2 is rotation at C. D2 is rotation at C. Okay, we move to label number 3. D3. Okay, please look at D3. Okay, for deflection at position 3 tu, D3 means D3
Delta at A.
yes, delta at A. D3 means delta at A. D4 is
Rotation at A.
Rotation at A. Rotation at A. Next, D5. D5.
Delta at B.
Delta at B, D6, delta at C. Okay, delta at C. So, you kena try untuk sketch benda ni and try untuk understanding the label tu, the label that we label in numbering D1 sampai D6 tu, we should be able to understand it. Okay, where is the position it reflecting either delta or theta, sebab it is important because beam question kalau stiffness method, okay, soalan dia tak tanya sebab label, you yang kena label. Kan bila degree of freedom ni student yang kena label. So 1, 2, 3, 4, 5, 6 tu ikutlah nak label macam mana pun. As long as kita label dulu unconstrained system. So mungkin contoh contoh student A label dia 1, 2, 1 tu dekat B. Kan orang lain label 1 tu dekat C. So tak kisah label macam mana pun. Soalan akan tanya calculate rotation at C. Contoh soalan akan tanya calculate rotation at C. So rotation at C tu ikutlah siapa yang label C tu S1 dia akan bagi jawapan D1. Siapa yang letak degree of freedom dekat C tu label dia tu, dia akan bagi D2 representing the rotation at position C. So samalah, it is why the degree of freedom ni is just to guide us, kita yang label, to guide us what to represent the joint. Okay, so kita kena faham lah, one representing A, representing B, representing C. So kita kena faham all this position. Okay, so it is about deflection. So when we look at this in terms of Q pula, Q baru kita tengok forces. Kita tengok forces. So dalam diagram asal ni dia ada UDL, dia ada point load kan. Dia ada point load, lepas tu dia ada moment. Okay, dia ada point dan dia ada moment. So yang ni nanti saya akan explain in the next video macam mana kita nak baca Q pula dekat diagram ni. Sebab Q ni in this case, in this beam we have beam ni, sebab dia ada, perasan tak, beam ni dia ada ni. Dia ada roller macam ni. Tapi dia ada UDL and dia ada moment. Dia ada moment macam ni. Dia ada moment kan. Okay, so this is P yang tadi, this is moment yang tadi 30 tu kan, tak ingat yang ni berapa W. Okay, so we have A, B, C. A, B, C. And kalau kita pakai, for example, kalau kita pakai the standard equation, it is Q is equal to KD. And what is the definition of Q and D? Q ni is actually called as nodal displacement. Okay, and D is nodal forces. So what is the meaning? Okay, nodal displacement means displacement which is located at nodes. And nodal forces mean forces at nodes. Okay, reaction semua dekat nodes lah. Reaction dekat support kan reaction nodal forces. Dia akan jadi, so some, terbalik saya tulis. Okay, yang ni terbalik Okay, displacement tu and forces tu kan. Displacement and forces ni, okay, nodal displacement and nodal forces. Okay, kita baca reading tu dekat joint, dekat nodes. That's why we use the word nodal force, nodal displacement. Tapi dekat sini, P dengan W ni nak letak kat mana? Do you have any idea where we need to put P and W? Because kalau by definition, Q means nodal forces. D means nodal displacement. Of course, dia takkan masuk dekat D lah sebab D tu displacement, dia akan masuk pada kategori dia, kategori forces. Tapi where to put P yang dekat diagram tu, AB, yang dia subjected on the member. Dia bukan at joint, dia bukan at A, dia bukan at B. and W. Where to put W? Because W is subjected along the member. Tapi yang kita bincang tadi or bincang before this is nodal forces. Forces that is subjected directly at node. So where we need to put the P which is on the member and W which is also on the member. So kat mana nak consider this? Okay, kat mana nak consider this P and W? Do you have any idea? P and W? Do you have any idea about P and about P and W where we need to put or to consider in the calculation? Ada idea tak? Any idea where to put P and W? Okay, P and W. Kat mana nak letak? Tak ada idea. Maknanya tak tengok langsung nota or textbook before you enter the class. Kat mana nak letak? Kat mana nak consider P dengan W ni? Kat mana nak letak ni? Saya tak boleh terus tunjuk example sebab without understanding the concept, you akan nampak example tu susah. But if you understand the concept, memang kalau part bila nak explain concept, the first, okay, the introduction of each topic tu, bila part konsep memang you akan nampak benda difficult. Lebih-lebih lagi kalau you tak baca before you enter class. That's why saya dah ada mention. Saya ada mention nak masuk kelas baca dulu. Because kalau this is the first time you dengar benda ni, memang you have no idea. So what you should do is you have to at least read something or watch something before you enter the class. At least you have the idea about this, not just wait and wait. So saya pun kena tunggu dan tunggu. Okay? Tak ada idea langsung ke mana nak letak P dengan W. And video-video yang saya buat regarding stiffness method, saya tengok memang tak full yang tengok. Ada yang 20 orang tengok, ada yang 30 orang tengok, ada yang 15 orang tengok. Student ada 100 orang. Means ramai lagi yang tak tengok langsung. So kalau trust pun you tak tengok, macam mana you nak analyse beam? Sedangkan stiffness method, matrix method, stiffness method is topik yang paling senang dalam structure, dalam indeterminate structure. Topik paling senang nak score full mark adalah stiffness method. Tetapi kena make sure you tengok dan fahamkanlah. So video-video tu bukan sekadar saya buat dan saya upload kat YouTube. Untuk you tengok dan saya tengok viewers memang you tak tengok lagi. Kalau trust pun you tak tengok langsung, macam mana you nak faham beam? Sebab beam and truss and frame, beam yang paling complicated. Beam yang paling complicated. Even though formula for K is not complicated like frame lagi complicated in terms of formula, tapi in terms of process, in terms of macam tadilah kita nak compare between deflection and theta, macam mana kita nak relate dengan label-label yang kita pakai D1 until D6. Kalau you trust pun tak tengok, you memang tak boleh buat beam. Okay, so I want you to tengok balik all the video, try to understand. Okay, bagi saya jawapan apa kita nak buat. Okay, to include P dengan W dalam stiffness equation. What happened to this? What happened to this equation? Where to include P and W into stiffness equation? Kat mana nak include dalam ni? Okay, yang ni saya nak you buat. Saya nak you buat video 1 minit cerita macam mana nak include P dengan W. Okay, 1 minit video. Baca, cari you pergi baca atau you pergi tengok mana-mana video. Okay, dan explain in 1 minute video dalam Flipgrid dan saya assign macam mana nak include P dengan W dalam ni. Compulsory as entry for your test. Kena buat. Okay, macam mana nak include P dan W. Okay? So I cannot continue because you tak ready pun nak learn benda ni. Okay, you have to read something before you enter the class so that you akan dapat benda tu. Kalau you tak baca langsung, you masuk kelas, kesian pada orang yang baca. Sebab ramai yang tak baca daripada yang baca. Okay, so I want you to make 1 minute video using Flipgrid. Saya akan assign Flipgrid tu lepas ni. You upload 1 minute video, explain macam mana nak include P dan W dalam equation, dalam stiffness equation. This is the stiffness equation. Okay? How to include P and W in the stiffness equation to analyze beam. Explain in 1 minute video. That's why saya pernah cakap, kalau you tak ready, jangan masuk kelas. Because you masuk kelas, you buat saya rasa upset. Bila you masuk kelas, you tak ready. Because I do everything for you, tapi you tak prepare for your own benefit. Okay, so you balik study dulu. You study dulu about sekejap je. You cari 10 minit, you dah boleh dapat answer. How to include P dengan W dalam stiffness equation. Macam mana nak include P dengan W tu. Apa kita kena buat. Apa dia punya equation. Pergi cari jawapan tu and submit. Okay. So I don't want to continue because you tak ready pun. You tak tengok pun my video. Okay. So I need to stop now. Kalau ada soalan, PM tepi je. Teams chat. Okay, so I will end the session now. So we close this session with Tasbih Kifarat and Surah Wal-As.